Welcome to Pharma Drama, the channel where we look at the science of healthcare and healthcare products. In this video, I want you to get acid sorted. So all you need to do, acidly, is get yourself a drink, sit back and relax. Acids are a special group of molecules that you have probably heard of because they are quite reactive. In general, acids react with almost anything, which is why they have a quite fearsome reputation. Think of dissolving bodies in Breaking Bad, for instance. But actually, acids come in all strengths, from very strong to very weak, and you are probably familiar with some. For instance, when you eat food and swallow, the food is broken down in your stomach by hydrochloric acid. Hydrochloric acid is very strong, which is why your body uses it in this way. Imagine, however, that you've just eaten some fish and chips. I'm English, okay? Fish and fries? It's just wrong. And you'd put vinegar on your chips. Would it surprise you to know that vinegar is also an acid? It's called acetic acid, and the reason it doesn't simply dissolve your food is that it's a weak acid. I shall return to what exactly makes acids strong or weak in a moment. First, I need to define what an acid actually is. Simply, an acid is any organic molecule that can release a hydrogen ion when dissolved in water. A hydrogen atom is given the symbol H, and it is the simplest atom, containing one proton and one electron. An electron is negatively charged and a proton is positively charged. So in combination, they form an atom that is electrically neutral. When an atom either loses or gains electrons, it becomes an ion. If it loses one or more electrons, it becomes a positively charged ion, and if it gains one or more electrons, it becomes a negatively charged ion. When atoms combine to form molecules, they share their electrons to bond together. We can write the chemical formula of an acid as AH. The H represents the hydrogen atom and the A represents the rest of the molecule. The A and the H have formed a bond by sharing an electron. So far so good. But to understand what makes acids so reactive, we have to consider what happens when we dissolve an acid in water. Water, I remind you, has the structure H2O. Two hydrogen atoms sharing electrons with one oxygen atom. When we add an acid to water, each acid molecule is surrounded by lots of water molecules. Since molecules are really collections of atoms held together by the sharing of electrons, sometimes when different molecules are close together, some of the atoms choose to jump from one molecule to a different molecule, if they find the other molecule more attractive. Think of atoms as being rather promiscuous. In this case, the hydrogen atom of an acid prefers the idea of bonding with a neighbouring water molecule, and so jump ship. When the hydrogen atom leaves the acid, AH, it has to leave its electron behind, and becomes a hydrogen ion, H+. Because, as I noted earlier, a hydrogen atom comprises only a single electron and a single proton. A hydrogen atom missing its electron is called a proton, because that's literally what it is. So we call H+ a proton. When a proton leaves an acid, what is left behind is the rest of the acid molecule A with the extra electron. So it becomes a negatively charged ion, A-, and we say that the acid has dissociated. The proton, now free of its partner, binds instead to a molecule of water, forming a new ion, H3O+. This also has a special name. It's called a hydronium ion. So we can write a chemical reaction for what happens when an acid dissolves in water. AH and H2O gives A- and H3O+. And that is really all an acid is. It's a molecule that can donate a proton to water when dissolved. Why do acids have such a fearsome reputation? It's because the hydronium ion is very reactive and will react with almost anything. This is why acids degrade a lot of things. I said I would return to why some acids are strong and some are weak. The answer is because when a lot of acid molecules are dissolved in water, not all of them will dissociate to release their protons. Only a fraction will dissociate. So, if only a small fraction of the acid molecules release their protons when dissolved, only a small number of hydronium ions will form, and we say it is a weak acid. If, on the other hand, nearly all the acid molecules release their protons, then a lot of hydronium ions will form, and we say it is a strong acid. So whether an acid is termed weak or strong simply means what fraction of the acid molecules will release their protons when dissolved in water. Hydrochloric acid releases nearly all its protons, so is a strong acid, while acetic acid releases very few protons and so is a weak acid. That leaves me only a few other points to note. We can characterise the acidity of a solution by measuring the concentration of hydronium ions. The more hydronium ions, the more acidic the solution. We use the term pH to define this concentration. I'm sure you've heard of that. We can also characterise an acid in terms of what fraction of protons will be released in water, and that is termed its pKa value. If you haven't heard of that, don't worry, there are separate videos for pH and pKa on the channel. Finally, it is possible that acids can release more than one proton. If an acid can release 2 protons, such as sulfuric acid for instance, it is called diprotic. If an acid can release 3 or more protons, such as phosphoric acid, it is called polyprotic. Right, I hope you found that description useful and acids make more sense to you now. If you did, please hit the like button and consider subscribing, as it really helps the channel. There are loads of videos available describing science concepts, so please browse them all. Otherwise, thank you so much for watching, and I'll see you again soon.